Our next chapter, chapter 16, is on aldehydes and ketones. And the first thing that we are going to do is just review the structure of the functional group. What does an aldehyde look like? What does a ketone look like? And we're also going to learn how to name aldehydes and ketones. So let's start by drawing an aldehyde. I'm going to draw like a generic representation of an aldehyde. An aldehyde has a carbon-oxygen double bond, and on the carbon, one of the things attached to it is a hydrogen, and then there's going to be something else attached to the carbon as well, if we're going to abbreviate with an R, and whatever that thing is that's attached to the carbon, that R group on there, that could be a hydrogen, it could be a second hydrogen, or it could be a carbon chain, or just a single carbon. So that's the aldehyde. And then let's draw over here, let's draw the ketone. The ketone also has a carbon-oxygen double bond, but the difference between an aldehyde and a ketone is that there cannot be any hydrogens at all attached to that carbon. So both of these must be carbon chains. Neither one of them can be hydrogens. And that's what it, if either one were a hydrogen, then we would call it an aldehyde and not a ketone. So I'm going to go over the naming rules, how to name aldehydes and ketones, and then we're going to go to a worksheet where we're going to actually practice with some names. So this is just going to be steps without an example, and then we're going to do a worksheet with some examples. So like usual, the first thing that we have to do is find the longest carbon chain. And this carbon chain is not necessarily the longest carbon chain in the molecule. It has to be the longest carbon chain that includes the carbon-oxygen double bond of the aldehyde or the ketone. Then we want to number the carbon chain. And when we do this, we're going to start at the end that is closest to the carbon-oxygen double bond. Just like usual. Then, before we put the name together, we're going to do our usual locating and naming any substituents that might be on the carbon chain. Locate and name substituents or branches that are on the carbon chain. They'll come first in the molecule's name. And then we are ready to put the whole name together. So we are going to use the parent name, which is going to be based on how many carbons are in the longest carbon chain, based on the number of carbons in our longest chain. We are going to change the ending of the parent name by dropping the E off the parent name and replacing it with either al, if it's an aldehyde that we're naming, or own, if we're naming a ketone. Now, another thing that we have to include is the location of the functional group if we are naming a ketone. So we're going to make this in red right here. If we have a ketone, don't forget to include the carbon, the number of the carbon, the location of the carbon-oxygen double bond along the parent chain. So don't forget to include that, just like you would include the location of a carbon-carbon double bond or the location of a carbon-carbon triple bond. We're also going to need to include the location of a carbon-oxygen double bond. If we have an aldehyde, it is not necessary to include the location of the double bond. So that's a lot of rules. Let's go to a worksheet and practice it.